Hello everyone, welcome to my channel. My name is Rishabh and today we will discuss about real-time filtering. So in Instagram, whenever you upload your photos, you must have used all these effects where you blur your image or give it a warm or sepia effect or produce negative of your image. Today we'll be discussing about those effects only. In this project, I have done some of this real-time filtering. So basically what I have done, let's see all these things. After that we'll discuss about this. So in this project I have made it like whenever I press G, it will give me a grayscale effect. H will also give me a grayscale effect, but it will be some kind of different. B will give me a Gaussian blur. X will detect basically the horizontal edges and Y will detect the vertical edges. M will give me the gradient magnitude. Gradient magnitude, it basically represents the strength of the intensity change. Okay, and I will give me the quantized and blur image. C will give me the cartoonization effect that I have implemented on my images. P will produce sparkles, blue color sparkles on my image. N will generate the negative of my image. W will give it a reddish brown color, or you also say it warm or sepia effect in our image. F will basically flip the image. In this project I have flipped my image along the Z axis. S will basically save the image and Q will quit the image. So let's go through what is all that. So here when I say about grayscale, so as you all know that the colored image, they basically contains three channels, that is the BGR, okay, or RGB, that represents the color information. But in grayscale, images only have one channel that represents the intensity and brightness of each pixels. So by converting the image to grayscale, we basically reduce the complexity of any image and make it very easy to analyze and process the data. After this, I have implemented here the Gaussian blur function. So let me tell you, it is one of the most useful blur filter all over. It is also called as low pass filter. It is basically used to remove all the low pass frequency or the noise from our data. So it is done basically by convolving each point in the input array with a Gaussian kernel and then summing them all to produce the output arrays. After this, I have implemented our Sobel filter, which is basically used to detect the edges, the Sobel X is used to detect the horizontal edges and Sobel Y is used to detect the vertical edges. It is also known as the high pass filter, and if we talk about Sobel, it is basically the discrete approximation of the first derivative of a Gaussian. So it basically emphasizes over the edges in any image. Although the first derivative is not very symmetric operation, that's why here are two filters, one for X direction and one for Y direction. Now if we talk about our other function, that is the magnitude. So gradient magnitude basically represents the strength or magnitude of the intensity change at each pixel in the image. So let's suppose if we increase the magnitude, if we higher the magnitude value, then it indicates the stronger intensity change, which often corresponds to edges or boundaries. So here I have shown this how to implement this magnitude filter. After this, I have implemented a function that blurs and quantizes a color image. So quantization is basically a process of reducing the number of distinct values or levels in an image. It is very commonly used in image processing to simplify the representation of data, reduce memory requirements, and compress our image. So by reducing the number of levels, quantization can sometimes result in loss of some fine details and introduce some levels of approximation or noise in the image. That's why we always keep the number of levels very high, so that the image will appear more smooth and more visually continuous, more accurate to the representation of original image, and it may reduce the posturization also. After that, I have used this cartoon function, implemented this cartoon function to give it a cartoonization effect to my to my image. So here I have used, you can see the Sobel X filter and Sobel Y filter. After that, I have also used the magnitude filter. Then I have blurred and quantized it to make it to give it a quantization look, to perform this function. After this, I have used this negative function, which basically generates the negative of my image. It is done basically by subtracting the values from 255. 255 is the value in color space that represents white. Sepia, okay, so sepia, it is basically, it generates give a warm effect to a color, to our image. It gives a reddish brown color to our image. So it is calculated by this function, and we have to do this calculation. You can find this calculation in the internet. I have used this only to find it. And in the last, I have given our images this sparkles to the edges by using canny edge detector. One more thing I have done here, I have directly used the flip function to flip my image along the z-axis. Okay, you can also flip your image along the x-axis and y-axis also. So let's see how all these things are working. First of all, let me clear all these things. Okay, first of all, I will make my program to see if it's working accurately. Here it is showing 100%, it means that it is correct and it is not showing any error. After that, I will run. So my main file is in this folder, so I have written here src.main. You just have to put your location. Okay, let's run all these things one by one. When I press G, okay, so yes, it is giving me a grayscale image. If you see this, after H, yes, you can see here it is also generating a black and white picture, but in some different way. When I press B, it has blurred my image. I can also save it, and so that let's compare this, if it's really blurring my picture or not. When I'm pressing S, it is clearly writing here that image is saved. Let's see. Okay, let's go. Here I can see output image and the blur image. Okay, this was my original output image. Let's see. And this is the blur. You can see little bit of fading is done here. See, output, blur, output, blur. Right, now let's see other effects. Here, after, let's press X. Okay, so here you can see all the horizontal edges. It is very clear. Let's see my cap. All the edges are very clear. Let's press Y. It will give me all the vertical edges. Now M will give me the magnitude, the change, intensity change. I is giving me the quantized image. If you see it very carefully, let's save this and see it is producing some kind of noises here. Let's save it and compare. Okay, so here is my gradient image. Okay, see my face, there are some noises present, but see the output image, it is very clear, and see here. Okay, let's continue. After quantize, let's see the cartoon. See, it is giving me a cartoon effect. Let's see if I rotate it like this. Yeah, see how clear it is. Right? After cartoonization, let's put sparkles in our image. Oh yes, you can see wherever as I told you, I have used canny edge detector here. So in all the edges, it is producing this blue sparkles. Now when I press N, it is generating a negative of the image, and pressing W, it is giving me a warm effect to my image, or reddish brown color, or sepia you call it. After pressing F, it is giving me a flip image. So that's all for today. This was my first project, and all thanks to Professor Bruce Maxwell. So I did this project under him. Let's put it back. It is giving me, yeah, so now it's back. Oh, this one is good. Cartoonization, this one is good. Okay, so this project was done under Professor Bruce Maxwell at Northeastern University, and the course number is CS5330. Okay, thank you so much. After pressing the Q, it will quit